Hi, welcome to the Signal Path. In this episode, I'm going to talk about the 5G network, and this was prompted by the strange conspiracy theories linking the COVID-19 virus to the 5G communication network, and in general, some concerns about the safety of the 5G technology. I hope that you find the information in this video useful, as I also try to answer some questions at the end about science and about the 5G network in general. So let's go ahead and see what's going on in social media. Well, there's a lot of misinformation that's constantly being shared. It's only a sad sense of irony that misinformation about the virus spreads like a virus itself. One of the top shared stories is that Bill Gates created the virus, which is of course ridiculous. His work in the domain of trying to help treat and test for the virus has been exceptional. But the second most shared piece of information seems to be that 5G causes the COVID-19 virus, which also is of course ridiculous. These things have nothing to do with each other. But this seems to have come about because of some relationship between the fact that 5G towers were installed in the Wuhan city at the same time the virus emerged. And there's some reports that Wuhan city is where the virus originated from, and therefore this must be connected. But of course, correlation doesn't mean causation, and these are completely separate entities, have really nothing to do with each other. But I think most of this comes about because people just don't understand what 5G is all about, and it is easy in times of fear to be concerned about these things and to want to solve it in some way. But the problem is getting more and more serious. In the UK, people have been burning 5G towers and have been threatening 5G engineers, and in fact have now been recently attacking 5G engineers because they're working on this technology. One of these graffitis says 5G Wi-Fi is bad, which is only sad because 5G Wi-Fi has nothing to do with the 5G cellular network, which is what they're afraid of in the first place. 5G Wi-Fi is the 802.11n wireless Wi-Fi communication standard, which operates at 5 GHz. Whereas 5G network is the evolution after 4G LTE. It's a totally different thing. Aside from the fact that they're both wireless, they really have nothing to do with each other. But this is not the first time people have been afraid of technology, and it certainly won't be the last time. In the early 1900s, when electricity was being introduced, people were really afraid of it. And this is one of the posters that was created at that time against the distribution of electricity. And there's some truth to this. If you're hanging in the cables at high voltage, you would have a bad time. In fact, this picture would be fairly accurate in that case. And you can sympathize with them. This is what streets used to look like from all the power lines and telegraph lines that were running around. Now, technology has moved on so much, regulations have changed so much that the streets don't look like this in most places. And you can see why people would be afraid of it. Now, this doesn't mean that electricity is not dangerous. It all has to do with how it's deployed. So there is some concern about, there's some truth about the fear, but of course it depends on how we use it. So why is 5G special? Why do we talk about 5G in a different way than we talked about 4G LTE or 3G? What is making it special? In fact, the technology that we're trying to use in 5G is truly special, and it's very difficult to deploy, and that's one of the exciting parts about it. So it all has to do with how we've been doing wireless communication for about 100 years. Now, Marconi is said to be the first person who's done wireless communication. That's one of the examples here of what he used to do when he was only in his 20s, by the way. And he basically had an antenna that would emit EM energy, broad spectrum EM energy, which you're not allowed to do anymore. And then you would have another antenna that you would catch that signal with, and you could create a wireless link where you could turn something, let's say, on and off. This was the first instance of doing that. The funny thing is that if you look at how wireless communication is done in between most people in cellular technology or Wi-Fi or Bluetooth, it still uses the same principle. What we do is that we have an antenna that emits EM energy in all directions. This is isotropic radiation, so it goes in every direction possible in an ever-growing sphere, like a light bulb. And on the other side, you have an antenna. If the antenna can catch even a tiny amount of EM energy that is in space, is enough to create the link. So your Wi-Fi works like that. And this is amazing because almost all the energy is basically wasted and only a tiny amount of it is caught by the receiver antenna. But because our electronics is so good, we can still create a wireless link even with this tiny amount of energy being captured. And this is what we've been doing essentially most of our communication. There are some exceptions, but this is the major consumer electronic industry. So if you look at why this is getting harder and harder to do, is because we need more and more data, and we had to upgrade almost every aspect of our network, our Fiber optic networks are getting better, our Wi-Fi technology continues to get better, our cellular technology gets better. And this is because every time a new technology is introduced, we just want more data. When Google came about, when Netflix came about, we just want to consume this information. And now commerce is of course a huge part of the internet, and that's a tremendous amount of data as well. This is, by the way, from The Future X Vision. It's a book by Bell Laboratories. So if you want to meet this demand, we have to do something about our communication network. So why are we at a dead end? Then why is 5G special? Why can't we just do what we did with 4G? Well, this picture, without having to get into the tiny details, shows you how the electromagnetic spectrum between 0 kHz to 300 GHz to the bottom right is divided and regulated. You cannot just transmit signal in any frequency you want or in any bandwidth that you want. You have to fit the FCC regulation, let's say in North America here. So what makes this plot special is because it's on a logarithmic scale, which means that every one of these squares, as you go down this graph, even though they're the same width, they represent much more bandwidth. So you can send a lot more information in higher frequencies than you could at lower frequencies. So your Wi-Fi operates at 2.4 gigahertz, let's say. A lot of cellular communication is at sub 5 gigahertz, but there is no bandwidth left. All of that is consumed. We just simply have no more room to cram more information at those frequencies. So we have to go to what's called millimeter wave frequencies. And this millimeter wave frequency simply means that the frequency is high enough that the wavelength of the signal is now in the millimeter range, less than 10 millimeter, which starts at around 30 gigahertz. So 5G, for instance, is supposed to operate at 28 gigahertz, at 39 gigahertz. Those are some of the bands that are open, and also sub 5 gigahertz. The sub 5 gigahertz part of it is very similar to how we used to do things in 4G LTE, with some exceptions. A lot of it happens in the background, you won't even notice. But the millimeter wave part is really exciting because we can put so much data with such low latency to create new applications. So why is that hard? Well, first of all, we need to understand how the electromagnetic spectrum works in general. And because of human ingenuity and because of the science that we've put into it, we can use almost every part of the electromagnetic spectrum. This would have been inconceivable a couple of hundred years ago. It's really quite incredible. So we use the really low frequencies for AM radio, which is still being used. As you increase the frequencies, you have cell phones, radars, and then you hit the visible range. That's what we use to see, of course. And if you go higher than that, you eventually reach X-ray machines, which is used for medical applications. So we have found a way to not just measure everything, but also use it for something, which is amazing. So is it dangerous? Is electromagnetic spectrum dangerous? Well, of course it's dangerous. Consider the sun that puts out a huge amount of EM energy, particularly from infrared, visible, and UV. And it's been shown that the UV energy from the sun, because of its small wavelength, can interact with the DNA structure in your skin, damage the DNA structure, and potentially cause cancer. So yes, being in the sun for too long is in fact dangerous, and it will harm your skin and increases your chances of getting cancer. What about at much lower frequencies? Well, we have our microwave oven, operating around 2.4 gigahertz or so. And it has a safety feature. If you open the door, it will not turn on. But if you break the glass and put your hand in it and then turn it on, it will burn you. That's because there is so much EM energy in there. That's how it heats up your food. It interacts with water molecules, for instance, and vibrates them and creates kinetic energy, creates heat, and that's how it works. So yes, of course it can be dangerous. You can even make weapons out of it. Here on the left, we have what's called an active denial system. This is a big antenna with an array function built into it that allows you to target an individual up to half a mile away at 95 gigahertz and give them the sensation as if they're on fire. Now, they're not, of course, on fire. It's because at 95 gigahertz, EM energy doesn't penetrate your body, but it heats up the surface of your skin and fools you into thinking you're on fire, and that's how you control the crowd. And this was deployed in some scenarios around the world. It's not supposed to be lethal, it's not supposed to have long-term effects. There's a lot of studies done on that, but I still wouldn't stand in front of it. Having said that, you can also use electromagnetic energy in the optical frequencies or infrared frequencies and build a weapon out of that. That's how lasers work, and shoot down planes and burn holes through things. And this is why various organizations around the world have very strict requirements of how to deal with electromagnetic energy. For example, the World Health Organization has a long list of recommendations of what you should do to limit your ultraviolet exposure from the sun, what kind of cream you need to wear, what it should do, how much it should protect you, and at the same time, The FCC has very strict radio frequency safety requirements. You cannot just deploy any kind of radio frequency transmitter anywhere you want. Not only do you have to meet the frequency requirements, you have to also meet the power requirements. These are regulatory entities controlled by the government, separate from all the businesses, to ensure that there's a decoupling between the people who create the technology and how it's deployed. That's how we do everything. Every technology is subject to these kind of regulations. So great. So we talked about that we want to create millimeter wave frequencies. So then what's the problem? Why don't we just do what we were doing before and just create transmitters that operate at millimeter wave frequencies the same way we were creating transmitters that operated at less than 5 gigahertz. After all, that's what your Wi-Fi does. Well, it turns out, without going into details, that as the frequency increases, the ability of semiconductor materials to generate power diminishes. It means that if I have a transistor can generate some level of power at 1 gigahertz, but a transistor that can generate power at 30 gigahertz cannot generate as much power. This has to do with semiconductor physics and the limits on how transistors work. So I cannot just build an antenna and hope that the antenna radiates power everywhere, and then I catch a little bit of it and make a link like Marconi used to do, because I can't generate enough power to afford to waste so much of it in free space. So I have to do something new. Now you may think that the technology to do that must be very recent. In fact, it's not. It was created by Carl Braun in 1905, which is quite a long time ago. In fact, there was a Nobel Prize associated with that. This is called a beam-forming phased array. It just looks like a shack with 3 sticks around it, but in reality these 3 sticks are antennas separated by a certain distance, and he could tune these antennas by moving these wires and do something that's called beamforming. How does that work? Well, in really simple terms, if I have lots of antennas and I can control how the signal gets to each antenna, and I change the phase of the signals appropriately, I can make the beams combine in the air and tilt them, as if I was taking a flashlight and moving the flashlight left and right. So the difference between a phased array when it comes to communication than the old isotropic communication is that the isotropic communication is like having a light bulb that lights up the entire room, whereas the phased array is like having a flashlight that focuses the beam of energy in only one direction. This is pretty amazing because you can move the beam around without having to move the antenna around, and that's a totally different thing, and this is because of destructive and constructive interference in the air. It's like ripples on a pond if you have multiple stones that you throw in at the same time. So this technology is amazing. In fact, because of the fact this, by the way, has been around for a long time, a lot of satellite communications use it, but we're now trying to deploy it at mass scale. It's very different to build something where you only use it occasionally in a few places where the cost can be very high. It's a totally different thing if you want to deploy it for consumer applications. So I'm a little bit biased, of course, so I'm going to show you the example of a 95 gigahertz phased array that has been done at Bell Labs. This one has 384 active elements, and you can do beamforming, and you can see how tiny these things can be because the frequency is so high. Antennas get smaller and smaller. In a very small area, I can have tons of antennas and move the beam around and follow people around with the beam and give them the signal that they need. This means that I don't have to waste energy by sending the signals everywhere. I only send it to the person that I want to communicate with. So if there are 10 people that I want to communicate with, I just move the beam between them very rapidly. And from their point of view, they can't even tell that this is happening. All they're seeing is this signal giving them data. So a lot of other work, by the way, has been done in this space. I'm just using the Bell Labs example. There is so much wonderful engineering in this space. So is it dangerous? Well, we can do some basic calculations. Let's go and calculate the free space path loss between 2 points. Free space path loss simply means that when a signal leaves an antenna, how much does it weaken by the time it reaches someone else at a certain distance? Let's only take 2 meters, right? So 2 meters, if you're standing only 2 meters away from an antenna operating at 28 gigahertz, there is 67 dB of loss. The signal is 5 million times weaker by the time it reaches you than when it left the antenna. That's how hard it is to make millimeter wave communication links work at all. The fact that we can do it is because of the incredible electronics we have created. It's not because we're putting out so much power at millimeter wave frequencies. We can't. The reason we're using phased arrays is precisely because we can't generate enough power. So there's so much reduction that you really don't have to worry about it. The fact that you can even get anything is a miracle. And also, even with this kind of loss at 2 meters, you're not allowed to go up against a tower. You're not allowed to put your face against a 5G transmitter. There are strict regulations of how far you can be. In fact, if you're standing in front of it, you would block the link completely and no one else can get any signal. So just simply by practicality, you're not going to be close to people. But even so, you're not allowed to go up into it. In fact, if you drive a 4G tower right now and stand in front of it, you can get harmed because they put out so much more power than you do at these frequencies. But they're also much higher, they also serve users much further, but you also cannot just climb and stand in front of it. In fact, the American Cancer Society has repeatedly addressed this issue, getting an aggregate of all the studies that have been done, and they repeatedly say the amount of RF energy that reaches individual users is so small that it does not interact with your biology. It cannot influence your body. It's so weak, and it's a non-ionizing radiation, and therefore you shouldn't have to worry about it. Now, this doesn't mean that we should stop doing any research. The research continues in this domain, and people look at this effect all the time. But let's put it in a different way. If you could build a 5G tower that could actually harm you, it would be an enormous engineering waste because you wouldn't need to put out so much power to create the link. So no engineer in their right mind would create a system like that. And all the links of all these articles that I'm talking about are also available in this presentation, so you can go and check it for yourself. So millimeter wave, by the way, has been around for a long time. It's just that because of 5G, people are now thinking about it. Your car uses a 77 gigahertz radar module. You are being exposed to 77 gigahertz millimeter wave frequencies all the time, every time you pass in front of a fairly new car. And also millimeter wave frequencies have been used for satellite communication. These things have been around for a long time, and there's no reason to think that they are harmful. There's nothing that shows that the tiny amount of power these systems put out have any risk toward human life. Now, 5G network itself can open up a lot of new types of applications because it offers very low latency. This low latency means that you can do things like augmented reality and virtual reality in real time, things that we cannot do with our 4G LTE network currently. The fact that we are stuck at home and we're relying on our communication network more than ever shows you the importance of having a solid, scalable communication infrastructure that can adapt to our needs and respond to emergencies like the one we are in. There's a lot of exciting technology that's behind the scene that you wouldn't even notice that's happening in a 5G network. So let me answer some questions, and I think these questions are important, and some of them touch upon some important points that are certainly worth considering, but some of them are also quite mistaken, and I think it's good to think about them. So one of the questions that always comes up is that science told us lead gasoline and cigarettes were safe, and so of course 5G engineers are going to tell us that it is safe because they want to make money. There's a couple of things wrong with this statement. First of all, science and scientists are not the same thing. Science is a process. It is our most committed effort to discover the nature of the real world beyond the limitations of our senses, especially beyond our human tendencies for prejudice, bias, and delusion. This process works. The fact that you're even watching this video is testament to the fact that it works. Scientists are not perfect, and any scientist who uses science either by mistake, in the wrong way, or on purpose is not behaving very scientifically. And the reason we know lead gasoline and cigarettes are not safe is because of the courage of other scientists and because the scientific method ultimately prevails, and you cannot keep the truth hidden forever. The people who lied about this are exactly that. They lied about this. This is not an inherent problem with science, it's an inherent problem with humans and potentially with our greed. It is also true that if someone's salary depends on something, you're not going to rely on them to determine whether it's safe or not. This is why I don't do 5G safety testing as my job at the same time as building a 5G network. That's why regulatory institutes, independent institutes do these studies. And that's why it has to be verified, it has to be in a peer-reviewed publication, it has to be tested again and again and again to to ensure that it is safe and continue to do so despite what anyone else says. And that is what is being done. That's why there's so much information about the safety of EM, electromagnetic radiation from cell towers, already exists. Again, note that this is not about whether EM energy can be dangerous or not. It can. It has to do with how it can be deployed in a safe way, which is what we've been doing for the past 50 or 100 years when it comes to communication networks. So there's some confusion in this question inherently. This is not about scientists, it's what about the scientific process itself. So the other question that keeps coming up is that unless you do research in the field of biology, you can't comment on how dangerous the 5G is to humans. There's also a couple of misunderstandings in this. First of all, even though I don't do research in 5G safety, the result of that research is certainly interpretable by other scientists such as myself. If it wasn't, then those two scientists in two different domains could speak to each other. I can feed information into the model that a scientist uses to determine its safety on humans, and vice versa. All these scientists work together in order to ensure the safety of this technology. Just because I don't do 10 different scientific domains under my belt at the same time doesn't mean that I can't comment or understand how it works. But aside from that, I'm not commenting whether 5G is safe or not. I'm saying that there is not enough power to worry about it. The analogy would be that I don't do research on skin cancer or safety of the sun on the skin, but I can tell you that you don't have to worry about getting sunburned in a dark room, which is exactly the scenario here. There's just not enough power for you to worry about. The other things that influence your body are much stronger than the amount of power you would get from a 5G tower. And finally, this question that keeps coming up is probably the most painful one to have to address. That science has been wrong so many times, and therefore science cannot be trusted. Again, it's so ironic that often this is in Twitter, using an extraordinarily complex communication network based on scientific theory that this keeps being asked. So let me answer that with a couple of demonstrations here. So here's a photograph of me holding the world's first transistor from the Bell Labs archives. And this, you can see the transistor. Here's the bipolar transistor. Often people think this thing is much larger when they see the photo in books and so on, but it's really quite small. And this is the original one, and that's why I had to wear a white glove to hold it before it was put back into the display while they were doing some renovations. But the phone that was used to take my photo, which was the iPhone 6s at that time, has billions of transistors. And this is from 1947 to 2017. If science didn't work, you wouldn't have this. Despite the fact that science can occasionally make a mistake, that's not a weakness. The fact that it constantly corrects itself, that's its strength. If it was never going to make mistakes, it wouldn't even be possible to have a scientific process. Of course you're going to have wrong information. Science also has a direct influence on our perspective toward others as well as our planet. We went from burning witches to burning rocket fuel to leave our solar system. This is an extraordinary transformation, and it's more than just a scientific method. It also has to do with the courage of the scientists that fought against misinformation and changed their point of view and replaced our fear with understanding, and an education system that teaches us how to deal with things that we don't understand well. Unfortunately, social media sometimes works against us, and the main reason is intuitively, you would think that social media would help, because you would think that by connecting to hundreds of other human beings or thousands of other human beings at the same time, it would expose you to a diverse set of ideas, and therefore the ideas that are correct, that can stand time and science, would then be the ideas that are accepted. But unfortunately, it turns out when you increase the human connectivity by a factor of 1,000, it polarizes us and it pushes us into different camps and keeps us within our own bubble of misinformation. That's why we should constantly fight this and have particularly courses that are just about critical thinking. Memorization is not so important anymore because information is free and is available all the time. What we need is a faculty of discernment to understand how to deal with information, how to understand whether something is true or not, and how to verify the correctness of any statement. At the same time, there are pretty dangerous misinformation out there. The anti-vaccination movement, the chemtrails, the people worrying about the trails that airplanes leave, and of course flat earthers. I mean, these societies exist and these people exist not because they're bad, but because they're misinformed. In fact, I would say, as others have also pointed out, that this is our failings as scientists and as educators, that we cannot push these people into the fringe of society and expect them to then operate normally. And more importantly, politicians can then fall in the trap of popularity of these ideas and then pass laws and regulations that can further push us back. We need to educate, we need to provide information, we need to have a conversation whenever these things come up. And this is the only home we have, and we are really well connected. This pandemic has shown that you cannot have isolated incidents on some parts of the world where other people do not feel. We really are in the same storm, even though we're not all in the same boat. And those of us who are more fortunate should take note of that and help and support and increase the spread of correct information so that we can get out of these situations faster. Same is true about climate change. That's one of those incidents that's going to affect us in much stronger ways than anything we're dealing with now. And we need to make sure that we understand it, we can fight it in a more reasonable way. We have to understand we put the correct resources on it. And these are all essentially science. This is what science is all about. It's the process all about. Education is supposed to help us with that. And I hope that you found this video useful and some of the information that you can also use to have conversations with other people. Let me know in the comment section what you